Few minutes and work on this. I do have your old DMRs. I'll hand back to you in a few minutes. Here's some answers for these. Please check those out. Number 1 has 3 different answers. Number 2 has 2 different answers, 2 different solutions. Number 3 has 2 different solutions. Number 4 is a hopefully lovely graph. It's sorry, got a little hard to see in the corner there. I can clarify that if you want. Anyway, think it over. Be happy to discuss with you any of those answers up there. Take it. We're going to be adding some fractions. So what she had you do last week is she had you work really hard on finding a least common multiple. Right. And so that's going to be the crux of what we do. So if we can find like each of those 2 denominators, yeah, so obviously you can see the difference. 15 x to the yes. So what we need to do then is figure out, all right, if the denominators are going to be that, how do we need to adjust the numerators to accommodate that? And once we have that, we'll be in good shape.
So for this one, to get this to 15 x for the top, since this is like this. Oh, what you need to do? What you need to do 3x the second time.
Correct. Top and bottom. What would you need to multiply by here?
This one we do 5. This is already x.
You're going to be in good shape. We'll just talk about the mechanics of how all that works, but that's what we're going to be working on. We're going to work on that again tomorrow.
Oh yeah, thank you.
Hey, do you guys have any questions on any of those? Let me point out one thing then that I saw. So I saw number 3, saw a lot of really good work. Number 3, we didn't have perfection there, but it was really good. Number 2, maybe not quite as good, but still good. I mean, in that, maybe not everybody used the most efficient way, but number 2 is pretty good. Number 1, I saw a lot of people that were missing one of the solutions. The first one, a lot of people had x equals 2, and a lot of people had x equals -6/5. That didn't seem like that was all that difficult for you guys, but a lot of people were missing x equals 0. So I'm wondering if you figured out, maybe you already figured it out. You already figured out where that came from, but if not, that might be worth discussing. Number 4, heard a lot of you guys kind of working through that together. That's the newest thing we've done. I thought you did pretty well with that. So that was good. Anything at all. Totally get it. It's been a whole weekend. Might be rusty. Anything at all?
I had 6
Just didn't seem right?
Well, no, I accidentally overwrote for number 1 and went into number 2.
Oh,
that was
gotcha.
the answer for number 2.
It was more of an accidentally erasing than anything. Gotcha. Okay. Anybody else? Any questions, concerns? Okay, so we'll be practicing this again tomorrow. All look good? Okay, fair enough. So just one last reminder, I don't know if anybody's come in here in the last couple of minutes. If you have not turned in your completed project yet, please do so, and we'll work hard to get those graded for you here soon. All right, go ahead and flip over to your second page. We got some examples. We're going to kind of piggyback off of what the teaching candidate did last week, and continue in our work with adding fractions here. And so, if you guys would take a look at number 1 with me, and I'm just gonna kind of quiz you and see how much you can figure out here. You probably can figure out quite a bit. In my other class, we've already done a couple of these, and that's why I put try with a partner. But you guys really didn't get to these last Monday with the teaching candidate, and so I'll take just a little bit of a different approach here. I'll just see how you're doing with this first one, and then maybe I'll just turn you loose on some of the other ones. So let me just ask you guys a couple of questions. In order to add fractions, this goes way back to middle school, 7th grade or something like that, 6th grade maybe. In order to add fractions, what do you have to have? Same denominator. And in number 1, you can see that that's clearly not the case right now, right? It's not true yet. So then this is what you guys worked really hard on with the teaching candidate last Monday, is you looked at things like this, and you figured out the least common multiple of expressions like that, right? Remember how she used the little faces thing, like what's missing and what's there and what's not there, to kind of get you guys to think about how to create these least common multiples? So what do you think? 3x to the fourth, 5x squared. What would you guys say is the least common multiple of those two expressions? 15? X to the fourth, right? You need a 3 and a 5, and you need an x to the fourth. So I'm just kind of wondering, like, I wasn't teaching you guys last time. I don't know how easy or difficult that was for you. Is anybody sitting there thinking, like, I get the 15, but x to the fourth, what? Or I get the x to the fourth, but the 15, huh? I'm lost? I would totally get it, because teaching candidate, different person, you guys did really well, but maybe you were a little uncomfortable. I don't know. You did great. It was about you guys learning anyway. It felt weird. Yeah. So she, like, I would say, just like my critique is that I think she focused on like the little details a ton without giving you guys like a big perspective of like, hey, here's why we're doing this, versus like, here's this little exercise to get good at this little skill, versus, hey, we're going to be adding fractions. That's kind of our point right now. So I can see why you would have been like, I get how to do this part, but why? Yeah. I get it. I thought she did really well at what she was working on, but it would have been nice for you guys to think, cool, but why? What's kind of the end goal here, right? So are you guys okay with the 15x to the fourth? This is where we just be like, hopefully really honest with each other and say, no, I don't get it, or yes, I do. I'm seeing a lot of like yes heads doing this. I'm seeing a couple of just like statue heads that are like not moving at all. I'm going to assume you're okay, because I think you're pretty smart and all that stuff, but we're good? Okay, so here it is. This is the parts you didn't get to last time. My question for you, and I really want you to think about this. Don't just blurt out an answer, because you might be right and you might be wrong. I want you to think about this. If my denominator is supposed to be this, 15x to the fourth, here's the question. How do I turn this and this, please don't blurt, how do I turn those two into that, right? Like, that's the question. Because if I could figure that out, then this is going to be over with fairly quickly. So think that through. Like, how could I turn this into 15x to the fourth? How could I turn that into 15x to the fourth? While you're thinking about that, I'm going to rewrite this, and then I'll hear what you guys have to say about that. So I got this, and I've got that. Okay, so any thoughts? Let's just look at the first fraction. How could I turn that 3x to the fourth into 15x to the fourth? What would I need to do? Just say it out loud. Oh, there it is. So if I just go times 5, I've got that lovely least common multiple. My denominator is there, and I'm good, except I'm sure you guys are thinking this. With a fraction, or any expression for that matter, you can't just change it. If that were the case, when I got my contract to work here at Valor, and I see like my salary for the year, I would just add like a half dozen zeros on the end of it, and I'd say, that's no biggie, right? You'd do the same thing, wouldn't you? Like, if that was allowed, if it was okay just to like change a number like that, and we haven't violated any rules or anything, or for you guys, you get your grades and it's like a 79, you just scratch out the 7 and make it a 9, and you're like, 99, yeah, right? Great year. 99%, that's really difficult to do. You can't just change a number, right? So if I'm going to multiply the denominator by 5, what do I have to do to make it right? Hey, guys over there that are just jacking around right now, don't do that. Whatever it is you're doing. Yep, Ben, you're right. You got to multiply the top by the exact same thing. So if I multiply the denominator by 5, I've got to multiply the numerator by 5. And in doing so, I fix things. And I want you guys to think about this. What's 5 divided by 5? So if we want to be real honest about this, haven't I multiplied this fraction by a strategic 1.
Yes.
I haven't changed the value at all. I've changed the form for sure, but I haven't changed the value. So with that in mind, what would I need to do to that second fraction? I'd need to multiply the top and the bottom by what to get that denominator where I want? Say it again, Ben. If I multiply by 3, that gets me to 15. Multiply by x squared, that gets me to x to the 4th. If I do the same thing to the top, once again, I have multiplied by a strategic 1. Y'all with me?
Yes.
Okay, now the first multiplication is really easy. The second one, a little tougher. Obviously, you know 7 times 5 is 35. The denominator is exactly what we were hoping it would be. Over here on the right, the denominator is exactly what we were hoping it would be. But the numerator,
It's a little funky.
what little funky, tricky thing do we got to do with the numerator? Might not be obvious.
Put it in parentheses and multiply.
That's one of the things she taught you, right? She said, you know, if you're going to be multiplying like this, perhaps it's a good idea to put this in parentheses, because it's a binomial, and multiply. And what's the property that we use to do this? Distributive property. Okay, that's right. So 3x squared times 3x would be 9x to the 3rd. 3x squared times 5 would be minus 15x squared. Well, finally, we are ready to add these up. I would get 35 plus 9x to the 3rd minus 15x squared, all divided by 15x to the 4th. And I would like to caution you on something. And I mean, I'm sure you understand after so many years of teaching things kind of like this, I see all kinds of mistakes that students make. And there is a really, really common one that happens here. And I don't know, I think that's tough to say. I think this develops in middle school. It's this addiction to canceling / the complete misapplication of canceling. You're going to be tempted to do this. This is one of those moments when if you're only half paying attention, this is going to mess you up. That's not my intent. My intent is to help you not make an error. There's going to be a temptation to go, oh, sweet. That is incorrect canceling. If you did that, maybe you worked ahead a little bit. If you did that, you're wrong. It's just flat out incorrect. And so what we're going to be doing over the coming couple of weeks is we're going to try to really work on and refine your skills about basically when and how it's okay to cancel stuff out and when it's not. That is not the time because the numerator is not in factors. Okay? The denominator more or less is in factored form. The numerator is not in factors. And so the thing you'll hear me say a lot is, if it's not factored, you can't cancel. If it is factored, maybe you can. If it's not factored, you cannot cancel. So my advice to you would be to hold off on canceling. Like if your instinct is to start canceling stuff, just stop. Likely your instincts are wrong. That's what I usually see with freshmen coming in. Usually they have really bad instincts about canceling. You might have good ones. I don't know. But most of the time that's the case. So let's just leave it as is, not even try to cancel anything. Okay? That'd be a good answer right there. All right. So then, seems like you got a lot of the pieces of the puzzle together there. Number 2 is a little more challenging. I would like to see if you guys can do number 2. Ready? Set, go. Probably be this. I don't know if you'd laugh or not, if you'd just be frustrated. If you took some quiz or test later on, and like the next day you're like, oh, I wonder how I did on the test. You look it up, you get on Schoology, and you look, all right, we're at math test, algebra 1 test, all right, cool. And instead of seeing like 82% or 75 or 91 or whatever it might have been, listen, you saw x minus 3%. Would you be a little confused? You'd have that look on your face of like, what? What would you ask me? What's x, right? Because if x is 100, all of a sudden it's a pretty good grade, right? If x is 40, all of a sudden it's really not a good grade. So x minus 3%, you wouldn't know what the value was. So what I want to do is I want to help you guys with maybe a little bit of yeah, this will work, a numerical way of approaching this. So if I had 5 over something plus 2 over something, and I had, let's see here, let's go 14 minus 3, 14 minus 1. So do you see how what I've written on the board? Hey, gentlemen over there that are still distracted, this maybe will help you. There was one of you that nailed this. The rest of you, I don't think, nailed it. Yeah. Would you guys agree with me that that is exactly the same as that up there on the screen, except I've replaced the x with a 14?
Yeah.
Correct.
So if you were going to get a common denominator here, wouldn't you look at this and say, well, gosh, I know what 14 minus 3 is. 11. 5 over 11 plus, well, I know what 14 minus 1 is. That's 13, right? So then how do you get the common denominator between, or the least common multiple between 11 and 13? You just multiply them. So I'm here to tell you that x minus 3 and x minus 1 are completely different numbers. I realize they both have an x in there, but they're totally different numbers, kind of like the 11 and the 13. So the way that you get the least common multiple there is you just go 11 times 13. The way that you would get the least common multiple here with the x minus 3 and the x minus 1 would be this right here. Least common multiple, x minus 3 times x minus 1. It's those two separate factors being multiplied together. Because we don't know what the x is. Whatever the x is, well, that would maybe change our strategy a little bit, but we have no idea what it is. So the only way we know how to do this is to multiply those two denominators together to get your least common multiple. Does that make sense? Now the step that, there was at least 3 or 4 of you that got to that. The step where I think you went too far, some folks went ahead and multiplied that out, used a box or some other method to multiply this out. I don't think you should, and I don't think you want to do that. Let's go back over here. Let's hear what you guys have to say about how we actually do this. The current fraction is 5 over x minus 3 plus 2 over x minus 1. So, if this is my least common multiple over here, what would I need to do to the first fraction to get that least common multiple for my denominator? Say again? You can't see it? Oh, I froze it. Sorry about that. There it is. What do I need to do to that first fraction? There you go. So I multiply the bottom by that, and then just like before, whatever I multiply the bottom by, I need to multiply the top by the same thing. How about the second fraction? What do I need to do to that one? Yep. And top, same thing. I still, to be honest with you, I would not multiply that denominator out yet, / ever. But I am going to do a little work with the numerator. So my denominators are still what they are. But my numerators, what property do you see happening in those numerators? That's right. So I'm going to get 5x minus 5 and 2x minus 6. And our final step will just be to add those up. When I add 5x minus 5 plus 2x minus 6, what do I get? 7x minus 11, that's right. So 7x minus 11 over that denominator gives me this. And once again, please, for goodness sake, resist the temptation to do this. Y'all watching?
Yes.
Please, for goodness sake, don't do this.
Why would you?
Oh, goodness.
No.
Can I answer that question? Because I've asked the same question. Why would you do that? The answer is, well, there's an x above an x. So I just start canceling stuff. Resist the urge to cancel things. We'll talk about the next couple weeks when and how to do that. So please don't do that. Okay, I'm hoping that you have some good building blocks on which to work with. Please flip over to the next page and we'll finish here. If you guys would, please try to do numbers 3 and 4. 3 should be pretty straightforward. 4 might be a little bit tougher. Hi, Joe. Thank you. All right, so here's number 3. And number 4.
Watch also.
What did you get for 3?
I got X to the third plus X to the third minus. Or minus 30.
I told you, Jaden.
Yeah, you're.
He gets mad because he's. Oh, that's my only pencil.
Oh, I see.
Maybe for those of you that are done with 3, I've got a solution up there for you. We can discuss.
I told you what.
Look very carefully. Make sure it's exactly the same.
Honestly,
I hopped this morning and like guzzled syrup or something.
don't ask me because it's like
This might.
70% not.
So.
Are you like caught in a crossfire or something?
Yeah, occasionally.
Yeah. So you made that one funny noise.
This is exactly what that is. I didn't.
In spite of your antics, Colton was like laser focused.
That what 3 is?
Did you get 3 right? I'll tell you right now, 4 is not.
Oh.
You want to hit? You want to hit?
How'd you get 18? You got shy? What'd you get for the report? Oh, hold on.
After you, because
I got 4x minus 18.
ended up being really large. You may or may not have a good value, but you still have to simplify it. Factoring that way, then let me Notice how I inserted some parentheses on the x plus 1 because I multiplied the top by x squared, right? And so I'm not multiplying just the x by x squared, which is what you did right there. I'm not just multiplying the x by x squared, I'm multiplying the whole square. I need to distribute the x squared across. And then you get x cubed plus x squared. But then notice you're
I'm done.
so that minus sign gets distributed also. It's like double distributed. Makes sense? Be really careful with the parentheses. Put those red parentheses in there. To me, make a big difference. Actually,
You and I were just
work. Guys, questions on 3? There's some details there that might be tough. Joe.
So would this apply to every one of the questions that we just multiply each side by the opposite denominator?
So I think in a lot of scenarios, yeah. In number 4, coming up next, you could still do that, but you're going to end up with a much larger denominator than you need to do some really serious simplifying to get there. We're going to find an easier way to do that. In a lot of cases, your proposal is right. It is. It would be the issue of, like, let's say, just picture this with me for a second. Let's say you had a denominator of 4 and 8. Let's say one denominator is 4, the other one is 8. What's the least common multiple of 4 and 8? 4.
All right.
No, that's the
8.
8, right? So, like, what's the smallest number they both go into? So, if I had a something over 4 and a something over 8, I'd say my least common multiple is 8. Every now and then, though, sometimes what people will do is they'll say, I got a 4 and an 8, my least common multiple is 32. Kind of what you're proposing.
Yeah.
And it's like, well, 32, like that is a common multiple, but it's not the least common multiple. The only problem that's going to cause you is in the end, you're going to have to do some reducing.
Yeah.
And with that, my scenario that we think very easy to do would be that big of a deal. With this, you're going to end up with this gigantic expression with like bunches of x's, like x to the 5th, x to the 4th or something, and you're not going to know how to back it.
Witchcraft.
So I'll show you that, or maybe that's not the best. Guys, this is your opportunity to ask questions about number 3.
You do the witchcraft.
No? All right, well, if you haven't already started number 4, please do. I'll erase this if that's all right. And I'll get that number 4 in a little better spot. And let you check that out. I'll give you just a moment here or two to continue. And by the way, what we'll mostly work on tomorrow is stuff like number 4. It's the toughest version of these. I'll give you a couple of minutes to try to explore with 4 a little bit. Do it.
Dude, I don't know because you confused me. Now I'm on a confused trail and I don't know where to go.
If you just take this, when you do x, you've got to just times x with x squared, so you get the x squared, right?
I did not get that.
5 and a negative power.
Yeah, but what do you do with this side?
This side, you already have this.
It's not fast enough. X plus 5 is already in.
Yeah, it's not. This side you don't have to do anything. It's already there. But you already have this part over on this side. So you just take this part of this side and bring it over here.
Like, could you get a better
So
grade?
then it would. So then you'd have x. You'd have that on both sides.
You can get above a 60 perfect.
You have the 4. And then yeah.
Okay, let's wrap this up. Finish up our class here. Like I said, tomorrow we'll be practicing more like this. So if this one didn't make perfect sense today, number 4, we'll see in the end. It's okay. We'll keep practicing tomorrow. Hey guys, did y'all notice that this is very factorable? So whenever you look at one of these denominators that are kind of like this and you say, I could factor that, you're going to want to factor it. Could be a really simple factoring, could be a little more complicated. If it's factorable, go ahead and factor it. So my first step would look like this. 2 over, this would factor as x plus 5 times x minus 5. That's that difference of squares pattern we've seen. You could use the boxes. We need to be able to get to a place where that's factored. Plus, over here, the x plus 5 is already a simple factor. I'll leave it as is. And I'm going to put that in parentheses because I've already seen what I'm going to do. I've got 2 denominators now. This one over here, that one over there. Do you see what that least common multiple would be? What do you think? Between the x minus 5x plus 5 on the left and the x plus 5 on the right, what do you think that least common multiple would be? And I'm going to write it in factored form, but yeah, you're right. You're right. So it'd be x plus 5 times x minus 5, which is x squared minus 25. That's definitely right. So then when I look at that left side, I've already got that, right? So I'm not going to need to do anything to that left fraction at all. The right side, though, is not what I want. Any suggestions on what I'd need to multiply the right fraction by, Coy, to get there? That's right. Multiply the bottom by x minus 5. Multiply the top by x minus 5. Notice how I'm being really careful with my parentheses. In other words, I'm putting them there. I'm not putting them there. Important for sure. Gentlemen, let's finish well, please. All right, so here we go. The left fraction just remains as is. The right fraction, distributive property. So it'd be 4x minus 20 when I do that. And then my final step would be to actually combine these. So what's 2 plus 4x minus 20? Yep, 4x minus 18. And I'm still not going to multiply that denominator out. I'm just going to leave it as is. There's no reason that I need to do that. If you did it, it's not wrong. But I would just leave it just like that. Hey, before you guys run off, I'll remind you of this a ton. 1 week from this Thursday, so like 10, 11 days from right now, that is your Unit 6 test. That means this is your window for doing lots of retries. And already a lot of you have said, hey, can I come in and do a retry on this or that? Continue to do so. We'll get you ready for that test, okay? Hope you have a great day. See you tomorrow.